each of these cases, what we want is what would x need to be for these lines to be parallel. Okay, so if that is the case, then I have angle 1 and angle 4. Okay, these are corresponding angles. So if I can set them equal, I can solve for my parallel lines here. So what I would do is I would take those two expressions, set them equal to each other, and solve the resulting equation. So here I would move everything to one side, giving me 2x squared. Since I have multiple terms with variables, I'm going to move everything to one side. So I'm going to add 5x to both sides, which cancels these out. And then now that leaves me with just one variable, so I'm going to isolate that. I'm going to move the 12 over. So that gives me 50. Divide by 2. I get x squared is equal to 25. And here's where the mistake tends to arise. If you miss this, when you extract a square root, you have to take into consideration the positive and negative root. More than likely, you did not if you missed this problem. And so what would x need to be in order for these lines to be parallel? Well, let's test each of these. Okay, so when I plug in a 5, okay, so I get 5 squared is 25, minus 5 times 5 is 25, minus 12. Can I have an angle that's a negative 12? No. So when I look at my two solutions, 5 and negative 5, 5 is actually extraneous. It doesn't plug back into the original form and give you a correct answer. Let me test negative 5. So I get 5 squared. Negative 5 squared is 25 minus 5 times negative 5 gives me plus 25 minus 12. And I want to see, do I get the same thing here? I have 38 minus 5 times minus 5 is plus 25. And then minus negative 5 squared is 25. So I test this. Is 50 minus 12 equal to 38 plus 0? Yeah, they're equal. So your only solution for that would be the negative 5. That's the only one that works. What would be the measure of angle 1? And we see here that angle 1 would be 38. Okay, and what would be the measure of angle 2? Angle 2 is the alternate interior angle with that, so that would also be 38. Okay, the next question, again, sort of resets. It's a different question. If angle 2, given angle 2 and 4, these two angles here are supplementary. So if measure of angle 2 plus the measure of angle 4 is equal to 180, well, what do you know about angles 2 and 4? They're vertical angles, so they are equal. So really, it's 2 times the measure of angle 2 is equal to 180, or the measure of angle 2 is equal to 90. So if angle 2 is 90, then that means angle 4 is also 90. And if angle 2 and 4 are 90, then its linear pair 3 will be 90. And angle 1, the alternate interior angle here, or corresponding angle between 1 and 4, also 90. So those would be your measures for that. Okay, what if angles 1 and 2 are complementary? Okay, if angles 1 and 2 are complementary, means that they add up to 90. 1 and 2 are alternate interior angles again. Therefore, I could think of this as 2 times the measure of angle 1 equals 90, or measure of angle 1 is equal to 45. So if this is 45, then that means angle 2 is also 45. And if angle 2 is 45, angle 4 would be 45. And the linear pair angle 3 would be 135 for that. Okay, the final part to this question, if I have the ratios of angle 1 to 3 is 4 to 5, what do I know about angles 1 and 3? They're same side interior angles, therefore they add up to 180 degrees. So if I used a part-to-part ratio, 4 to 5, I know that the smaller one is 4 out of how many total parts are there? 9. The larger one is 5 out of 9. And the whole parts is 180. So if I use my ratios here, 9 goes into 180, 20 times 4 is 80. And then here, 9 goes into 180, 20 times 5 is 100. And so there's my ratio. Angle 1 is the smaller of the two, so 80 degrees. Angle 3 is the larger of the two, 100. And then you just look to see. Angle 2 and angle 1 are equal. They're alternate interior angles. And then angle 4 and angle 2 are equal because they're vertical angles, or the angles 1 and 4 are corresponding angles. And so that gives you your solutions.